Alright, do you guys remember what we talked about yesterday?
Angles.
What is that?
That is parallelogram.
Parallelogram. These two sides are parallel, these two sides are parallel. Okay, so parallelogram is opposite sides, it's a quadrilateral, but opposite sides are parallel. What do the angles add up to in a quadrilateral, by the way?
360.
360. You remember how we find what the angles add up to in like a hexagon or something?
N minus 2 parentheses 180 over.
No, just that right there. So you take the number of sides, so hexagon would be 6 minus 2 times 180. What if we want just one of the angles in a regular hexagon or whatever?
Then you go over and
Divide by, okay. What's this?
that is a rectangle.
What makes a rectangle a rectangle?
All 90 degrees.
All 90-degree angles. What is this?
Rhombus.
Rhombus. What makes a rhombus a rhombus?
All sides are equal.
All equal sides. What happens when you combine a rectangle with a rhombus?
Square.
90-degree angles, equal sides. A square is a rectangle and a rhombus together. A rhombus, however, is not a square because it doesn't have 90-degree angles. A rectangle is not a square because it doesn't have equal sides. But a square is a rhombus and a rectangle. What came next? I think we did this next.
Kite.
And what makes a kite a kite? Besides it looks like a kite.
Other two sides are equal.
Two consecutive sides are congruent. Two pairs of consecutive sides are congruent. So it looks like that. And this is a trapezoid.
That's
What makes a trapezoid a trapezoid?
two top is parallel. The bases are parallel.
Bases are parallel.
See that?
Remember what I call these non-bases?
The legs.
Legs.
Goes there.
Geometry recycles a lot of words. If the legs are the same, I don't know if I mentioned this, it's called an isosceles trapezoid, because isosceles means two equal sides. I feel like I'm probably forgetting something, but that's pretty much it. Alright, now today we're talking about properties of parallelograms. Okay, well, the definition of parallelogram is the parallel thing. But guess what else we know about parallelograms besides the parallel line thing? Oops.
What's the right answer?
Guess what we know about parallelograms besides the parallel lines?
They go forever.
What do you think I can say about these two sides?
Equal.
They're equal. So there is a way to prove this. If
It
you
looks like a does statement though. So.
if you draw the diagonal, these triangles would be congruent, which means these are corresponding. Anyway, these sides turn out to be the same. So in a parallelogram, opposite sides are congruent. That's rule number one. How about angles? What do you think we can say about the angles?
They're all the same.
No, definitely not.
They're all different.
No. Also not.
Two of them are the same. The others are the same.
Okay. Once upon a time, we talked about parallel lines. And if you have a transversal, do you know what I knew about angles 1 and 2? Or what they were called?
Or same side interior.
And what did we know about them?
Add up to 180.
They add up to 180. These are parallel lines. So these two angles right here are like same side interior. Or these two angles right here are same side interior. Or these two angles right here, same side. So what they said was, actually, come on now. So let me go back and put number one. Opposite sides congruent. I could have said number one is opposite sides are parallel, like definition of parallelogram. skip that part though. 2 is consecutive angles. You guys remember consecutive from yesterday? Just means like one right after the other.
Yes.
Like these are opposite angles, these are consecutive angles. Like this and this, this and this. Consecutive angles are supplementary because basically they're same side interior angles between parallel lines. So they have to add up to 180. Well, if this angle adds up to 180 with this, and this angle adds up to 180 with this, guess what else I know?
That angle.
These two would have to be the same, or same thing here. These two would have to be the same. So, rule number 3,
I was right.
opposite angles are congruent. Now, this is not really on the list, but we also know the angle, all 4 angles have to add up to 360, right? Because it's a quadrilateral. But that's not unique. All right. Rule number 4. If you draw both diagonals, it makes like these 2 little triangles are congruent. So what happens is like this is the same as this, and this is the same as that. Which means diagonals bisect each other. Okay? You guys see what I'm saying here? Like this diagonal is cut in half by this diagonal, and this diagonal is cut in half by this diagonal. So these 2 are the same, and these 2 are the same. So rule number 4, diagonals bisect each other. All right. This is kind of, so those are all properties of parallelograms. This next thing's kind of, maybe I should have said opposite sides are parallel too. I'll skip that part. Something else though, if you have a parallelogram with one right angle, well, this has to be right because these 2 have to add up to 180. This has to be right because these 2 have to be the same. And so it's a rectangle. So if you have a parallelogram with one right angle, they're all right angles. It's a rectangle. Okay, one more thing. This is kind of a weird one, but if you have parallel lines and a couple transversals, if these segments are equal in length, then these segments are going to be equal in length. So, yeah, let's keep that in mind. We'll have to come back to it and talk about that one again tomorrow. So, on number 1 on the worksheet, if angle J is 140, what's angle L?
Would it be 140?
140. Opposite angles are congruent. You see how angle J and angle L look like the same obtuse angle?
Yeah.
And angle K looks like a small acute angle? So J and L are the same. What do we know about J and K?
They equal 180.
They equal 180. So which answers our number 3 question, how do I find angle K? 180 minus 95 is 85. Number 5. I know you guys have been looking forward to some algebra. How do we set this up and solve for x?
50 plus 9x plus 22 equals 180. Or,
Right.
Yeah, 180.
They have to add up to 180. So 9x plus 22. Did I zoom out? 9x plus 22 plus 50 equals So what is 108 divided by 9?
12.
Okay, it is just asking for x on this. Remember, sometimes they have us plug the x back in, so you gotta watch out on those directions. How about number 7? How could we set that up? Are they equal to each other, or did they add up 20? Yeah, 20. 7 is the same as 5, but 6 and 8 is not the same.
Yep.
6 and 8 are opposite angles, so they should be equal to each other. So 7 is, they add up 20. Let's see if I can do the whole problem without getting up. I'd be a little lazy. All right. So how do we do this? 7x and plus 6x. They're on the same side, so you don't like subtract 6x. You just put them together. So it's 13x.
13x plus 24 equals 180. Subtract 24.
I think it's 22. Am I right? Yes, all right. Number 9. What do we know about the sides of a parallelogram? The opposite sides are the same, so this is easy peasy. It's just 15. Number 11 is just 19.6. This is too easy.
Nah, this is hard enough. This is so difficult.
It's very hard for you. All right.
Low key. This is kind of easy.
On 17, it's not just asking for x anymore. So what do we need to do on 17?
Solve for x.
Solve for x, and then what?
Plug it in.
Plug it back in. So how do we set up 17?
Negative 4 plus 2x equals negative plus 7.
So yeah, 11's not the answer. 11 is what we use to get the answer. It's 17. So to find CD, we're going to plug 11 back in. So we got negative 4 plus 2 times 11, which is 18. Now that's the actual answer. Okay, why don't you guys turn to the back page, number 21. It says, there you go. It says CX is 10.3. So how could we find CA?
Times 2.
Right. So diagonals bisect each other, that means they're cut in half. So CX would be half of CA. So 10.3 times 2.
26.
Okay, 25, these problems you might actually get wrong. It says LJ is 12 and JN is 2x minus 6. What do we know about LJ and JN? They're equal to each other. So it's just 2x minus 6 equals 12. And solve that for x. However, on on 27, this is the one you might actually miss if you're doing it. Maybe not. You might get it right. It says ER and TR. How are ER and TR related?
R times 2 equals TR.
ER times 2 equals TR. Do you guys see where I got that from? ER is only half the diagonal,
Mm-hmm.
so if you multiply it times 2, that should equal TR. So 5x plus 9 equals 22 times 2. So you gotta be a little bit careful on those.
Are we on our own now?
Yeah.
Yeah.
Somebody not put their phone up.
Mine's up there. Wait, it's massive.
It's easier to tell when there's only 5 people.